All right. Good morning and good evening, everyone. I'm Tushar Dhaka, Senior Product Manager at Progress in the Progress Data Platform Product Division. And I'm very delighted to be your representative in today's webinar on how to develop AI-enhanced applications end-to-end. I'll provide a brief context for this webinar, and then Drew and Mike will be your guide for the end-to-end application development journey. So we are here because artificial intelligence crossed the barrier that impacts everyday business with ChatGPT. And so it's no longer the cool area of research that we occasionally read about and moved along. In fact, the rise of Gen AI has been nothing short of revolutionary, with the businesses across the globe investing heavily in its commercialization. However, the primary motivation is not just behind this investments goes beyond just profit, as most business leaders view Gen AI as an existential necessity for their organizations, and they are likely correct in their assessment. Gen AI has the potential to redefine how business operate, innovate, and engage with their customers, making it critical component for their future and for their success. So, despite its immense potential, Gen AI and large language models come with their own set of challenges. And in this next slide, we'll look at some of these challenges. The primary one of them is hallucinations. So Gen AI can be very confident in being wrong around 15 to 20% of the times. Their LLMs are then trained on some large data sets. And so there is a possibility of producing results that reflect data bias encoded in the training data. The lack of human reasoning and understanding can also lead to some stereotypical and incorrect results. The other thing is, since LLMs are trained on large data, there is a data cutoff. It means that there will be some information missing, like current events and in recent developments after the timeline when the model was trained. There is a lack of reasoning and reference to answers. So sometimes you don't know where a particular conclusion was derived from. And Gen AI also struggles with robustness against bad inputs and specific tasks. There are a few ways to address these pitfalls, and the most popular among them is retrieval augmented generation, or RAG. RAG is a framework that merges the traditional information retrieval systems and large language models. This approach combines the strengths of a database with the capabilities of generative models to enhance performance and reliability. In other words, along with the trained large language model, you can provide the system with your context, your data, which doesn't go into the training data, but it helps you provide reliable and consistent answers. To get the most out of this session, of this webinar, it is beneficial to have a basic understanding of LLMs and RAG, knowledge graphs, Java and LangChain J, LangChain 4J, React, and JavaScript. And what will you learn as part of this session? You learn how to develop your own Gen AI chatbot using MarkLogic Server, Semaphore, and related tools. Our goal today is to equip you with the knowledge and tools needed to harness the power of Gen AI effectively and responsibly. And with this context, I would like to invite Drew to talk through the end-to-end development journey with Mike.
Thanks, Thanks, Tushar. So we're going to jump into a brief demonstration first to see how our content is going to be used in an end user application. In this case, we're bringing in scientific research articles from PubMed, from the NIH. And what this allows us to do is set up a baseline set of data for our particular domain of interest. We'll see a traditional search application here, and I'm going to just go really quickly and show you the contents that we are searching against. In this case, I'm searching for glucose and GLP-1 keywords that are present in articles. We have quick aggregations and the metadata about those articles themselves, as well as information that comes from our knowledge graph in support of the questions. So we can see that we have content here in the system. It's one of those more traditional use cases for interacting with the data. So many of you may have an application similar to this today in production. And this underlying data can be used in conjunction with GenAI to ask questions. So I'm actually going to come over to a chat interface, and I'm going to ask a quick question: is what is the impact? Uh, uh, what is the effect on glucose in mice using GLP-1 medications? So this is actually using our private repository in conjunction with our knowledge graph, as well as the large language models to answer the questions. We found the most relevant data based off our questions, and the LLMs has synthesized a answer. We can even come into the articles and see the citational reference for them, come in, see the whole long abstract. We can see where this article fits within the world of our classification system, etc. And this is really how we start to enhance our applications with AI. We provide the we provide the end users an augmented experience with the LLMs and the generative AI, but always try to ground it within the context of their system, right? So in this case, we showed the answers based off of their content only. We also provided the citational links so they understand how the question was answered, so they can always trust but verify the information. So we go through a few different aspects here. And really, retrieval augmented generation with a combination of knowledge graphs allows you to encode your information with additional metadata and key concepts about your business domain. So it allows you to scale and be more efficient. You're able to define these key concepts within Semaphore, to define the areas that you want to model, and easily update and make new concepts and connections. And what this actually does is it increases your accuracy based off of the human in the loop factor, right? We have areas where we can ensure that our subject matter experts are defining the models and the information that they need to produce great answers. And it also helps in our consistent retrieval of content, right? So we ensure that everybody is speaking the same language, even if they may be talking with different labels or concepts. And we'll see that in a little bit as we dive down into our workflow. So the first step really is to start to bring in all your content, and MarkLogic is a great place for doing that. We have tools and capabilities to bring that content in, whether it is MarkLogic Flux to load and export data in a highly scalable way. We also have our Data Hub project that allows you to bring content in from different systems and integrate it. But getting that base level of content within the system is how we get our first leg up. The next step is that we're going to add context into the content. So as we start to ingest this content, we're going to classify it using natural language processing, as well as the knowledge models that we define in Semaphore. And that ensures that all the content that's coming through the system is tagged appropriately, organized in a way that we understand it as subject matter experts. The next thing is that we're going to enhance our querying. So as we typed in that chatbot, we've analyzed what the user's question was. So were able to determine what are the key concepts and paradigms that they were looking for. So determine that question, we determined that they were looking for glucose, mice, GLP-1s, etc. And the fact that the terms can be mentioned in many different ways is all encoded into the knowledge graph, which allows us to find the data more efficiently. Finally, we're going to augment the retrieval. And what that really means is after we find that content, we add it into the context of the prompt that's going to the large language model. And we'll see that in a little while as well, how we start to build up that prompt and ensure that that content is there for the large language models to interact with. And then finally, when we get that response, we have this interactions between the systems and the large language models through a middle tier. And LangChain does help us out with that in a tremendous way. So the end-to-end workflow really looks something like this. We ingest our content into MarkLogic. We tag it with semaphore to add additional contextual metadata. We allow the user to ask a query, which will then search those private documents. We'll provide a prompt along with the information that we find in those records to the generative AI, and it finally answers its question. So the first area we're really going to jump into is building the knowledge model, and we're going to see the use of an industry standard to build this model. You can start from many different ways for building your knowledge graph. And in this case, since we're working with PubMed data, they have a classification system called medical subject headings, also known as MESH. And we're going to start with that. And that defines, we can define rich metadata within there, enhance what is available in the industry model. We can supplement the model with additional metadata. And we can also supplement the model using AI itself, looking for additional concepts or labels. And then we're going to just briefly show how Semaphore classifies long form content. So we're in Semaphore now, and we're going to come over into our knowledge models. In this case, I'm going to pull up the PubMed knowledge model here, and we see we have medical subject headings. And this has a whole ton of first level concepts. But for our question, we were really interested in glucose. And we can come in and see this information, see where it exists in the tree, also visualize it in the context of its relationships in the graph. You can see glucose is also associated with sweetening agents. And we can see the metadata that's associated with it. In this case, the public model comes with a lot of information, things like alternate labels, concept identifiers, relationships. But we're also able to come in and enhance it. So we're adding our own definitions, adding our own images within here and notes. And this allows us to provide this additional information to the LMs, as well as enhancing our search experience. We'll actually look at sweetening agents in this case. And we talked a little bit about using AI to generate labels. So if we look at a suggestion here, we can actually send a out-of-the-box prompt to the large language model of your choice and start to get answers back. And so suggestions for additional labels. So sweetening agents, sweet tasting agents, sweetener additives. Another popular one is high fructose corn syrup. Now, if we look at this term and suggest labels, other types of labels come up: fructose sweeteners, saccharins, etc. So there's a lot of additional value that you can bring into your model and enhance it with your own knowledge. You don't have to completely stick to the industry standard one. Additionally, if you don't have a model, if you don't want to leverage a model, you can mine your own data for terms to start to build these knowledge models, or even bring in things like controlled lists that you have from other databases. So we do all that modeling for a key objective, and that's for classification. If we come into our document analyzer, we'll see content being classified. And we can see all the term and the terminologies and information that are part of the knowledge model are now used as part of the classification strategy for the content. So in this case, glucogen-like peptides are commonly referred to as GLP-1s. We can see, based off of the alternate labels and preferred labels, that GLP-1s are getting correctly classified on these contents. So Tushar, I think you had a few questions also around knowledge modeling.
Forgot to unmute. Yeah, so in which version is this GenAI assistance feature introduced in Semaphore?
Yeah, so in Semaphore 5.10, our innovation release for Semaphore has the capabilities of connecting to Azure OpenAI and using that as part of the concept enhancers, or whether it suggests new concepts or alternate labels for concepts that you already have in the system.
And how does one go about mining concepts? Let's say if I already have some documents lying around, how do I generate concepts out of this? Is there a way to do it automatically?
Yes, so in Semaphore, you can also load in the documents and start to mine them for additional tags and terminology. There's tools within Semaphore to handle that document upload as well as the mining of the content. It actually has a really robust natural language processing system underneath the hood there, where that you can extract things like key concepts, noun phrases, named entities, and all that great stuff.
Sounds good.
So the next thing we're going to look at now is that we have a model in place for the knowledge graph component, but we're going to take content from its original state, in this case XML articles coming from NIH, and we're going to define a few different things. We're going to take the content, we're going to chunk it, which means that we're going to take the bits of information out of that long form text and make it into small consumable pieces that the LLMs can understand. We're also going to create vector embeddings, and that is a numerical representation of that content that we can use as part of our data discovery and retrieval later on. We're going to classify the content as we've seen through the UI in Semaphore, but this is all going to be programmatically done. And then finally, we're going to define a template to link the content to the knowledge model so we can create an interconnected knowledge graph. So coming to VS Code real quick. So NIH, they publish the PubMed articles. These abstracts have a whole great set of metadata associated with them. And you can see we have things like titles and abstract text, authors, and all that great stuff in here. But this content is pretty long, right? And we want to store the original in the system, but we also want to create something that we can use for searching and sending that information over to the LLMs. MarkLogic being a multi-model database, we're able to load and save XML, load and save JSON, load and save graph information, and cross-query it at any time. So the Flux tool allows us to configure some properties that will actually take care of all this loading and chunking for us. In this case, we're just giving it a path to a folder with all these articles. We're defining our connection settings, the permissions that we want to associate with the articles. This is very important. In this case, we're using a default set of users, but you may have elevated permissions that you want to tie to role-based access control. So only certain articles get are viewable for certain users. Collections. We're going to put the content in a collection and tell it to kind of group all this content together. You can think of a simple tagging structure. The next area we're going to look at here is our splitting, and this is where the chunking happens. So we're going to look at our article title and our article abstract text for generating all these chunks. We're going to give it a max chunk size of 100,000 characters right now. Depending on your application, you may want to tweak this to generate certain chunks. Also, depending on the LLM you use, you want to ensure that you can fit in the context window. So you may need to adjust the chunk size, etc. In this case, since we know that the articles are pretty small, they're just titles and abstracts, we're just going to make one sidecar JSON file per article. In this case, we're specifying JSON as outside, We're going to create a root name for it, and then we're going to put those in a collection. So this will actually generate enough information for use in the Gen AI context and LM context. But we're also going to create a vector, and vectors allow you to do some additional things like re-ranking or discovery or similarity of content in a more computationally efficient way. So we're gonna use an embedder, and Flux allows you to configure multiple embedders. In this case, I'm using Azure OpenAI, but there's other options as well. You would specify your API key, and then we would also want to select the model. In this case, we're using the Ada 2 model. You typically use a smaller model for doing the embeddings because it can become quite costly if you do embedding for everything in your database with a larger model. This will allow us to get to a certain size. And we're just going to specify the endpoint for the LM itself. And finally, this last bits of configuration is the classifier. And this is where we're going to send we're also going to send these chunks to Semaphore for classification so we can have all this rich metadata. So if we take a look in our query console, we can see that we have content loaded in using these options. I just skipped over the loading and running the command for brevity of this webinar. But we can see we have chunks now within the system. And these chunks know which record it came from, the text that we extracted, the classifications coming from Semaphore, as well as the vector embeddings. So we're doing a true hybrid model here where we're using multiple types of search and data discovery paradigms to find the most relevant content. So we have our text, we have our classifications, and we have our embeddings. The next thing is once we have that content loaded into the system, we want to just create a TDE. And what this TDE does is allows us to put a view over the content. So we're selecting the source, the text, and the embedding. This is a new feature in MarkLogic 12, where we have a specialized vector index now. And in this case, we're going to pull that embedding that we saw here, and we're going to encode it as a vector. And this part is very important. Depending on the model you select, you have to define a dimension. And in this case, using that Ada 2 model, the vector dimension is 1536. So after we save this information, we're able to see a view of this data. We can run this over SQL if we want. We can run this over the Optic API, and we can see content how it's present in those chunks. We can also tie those classifications to the knowledge graph we defined in Semaphore. And what this allows us to do is say that this article mentions this particular bit of metadata, and then the knowledge graph contains all the other information around that particular domain of study. So it also allows us to discover the content in another facet. Okay. So Tushar,
so Drew, if I understand correctly, in this demo application, you are doing chunking along with ingestion.
Yes.
Then how does it work for documents that are already present in MarkLogic Server? If you just skip the ingestion process, how does chunking work?
Yeah, so we have a lot of customers that have tons of data in their databases already, terabytes, petabytes of information. Flux actually has a reprocessing option as well, where you can read the content from the database and then send it along to these other endpoints for classification with Semaphore, chunking, as well as embedding.
And are these chunks duplicated in the database or stored with a document with some reference, or they're just logical separation within the document?
Yeah, so It's up to you and how you store them. You can store them in the original content and store that embeddings and classifications within that content, or you can store them in a sidecar. Depending on your chunking strategy, the sidecar may be more efficient because you will have X amount of chunks that can be related to an article. So when we go into our search and retrieval, you may be looking for the only relevant chunk in a whole article. So, for example, when I was searching for glucose and GLP-1s, maybe only one paragraph of that article is relevant. So when you're having multiple sidecars, that allows you to adjust the relevancy for data discovery.
All right. I have a bunch of more questions, but I'll park it for now.
Sounds good. Okay. So the next thing we want to do is build an API, and this is going to be done in a middle tier. In my case, I selected Java just because that's what I'm comfortable with. But we also have examples in Python and Node if you're interested. But in this case, I'm going to define a query assistant and a prompt, and then from there, we're going to build a content retriever. And these are paradigms that are part of the LangChain packages. So query assistants and content retrievers are part of LangChain. They're interfaces that you will implement your code in. So as part of the content retriever, this is where we're going to do that workflow that we saw in the diagram. So we're going to analyze that incoming question for these key concepts. We're going to determine the best matching of these records using lexical search. And this is where MarkLogic is really powerful. We have a very robust search index and search API. We also introduced BM25 scoring algorithms in MarkLogic 12. If you're interested in tweaking the relevance, that's coming back. We also support traditional TF-IDF searching for relevance-based searching as well. We're going to use those vectors that we created to do a re-ranking. So after we go through our first phase of lexical searching, we're going to get the top relevant articles, but we're going to also do a vector similarity there to see how closely do those articles match up to our vectors. And then we're going to finally prepare that output for LangChain to generate the correct context to send to the LLMs.
So, Drew, conventionally, vectors are used for searching content.
Yep.
Why are we using vectors for re-ranking and not for the initial search?
Yeah, so what's interesting with vectors is that it's gonna do a similarity based off of an algorithm, in this case, cosine similarity.
Yeah.
Uh, but we're gonna use lexical search as well as like the key concept search because our knowledge model can contain a lot of information that the LLMs don't know about, right? So thinking about your internal business domain, you may encode things about your lines of business, your products, your research that you're doing. So the lexical search and the graph aspects of it allow you to get that information into the responses and find that content in your system based off of your understanding of it. So what you'll provide there is that information. So in a case where I typed in GLP-1, like glucagon-like peptide 1 is the formal name, right? And that's how the content's classified. We may have also internal names. So in our research, we may have products that are in development, right? That is not, it's using a code name um, instead of using a commercially viable name, right? So that's why we're doing the concept analysis and the lexical search prior to doing anything with vectors.
And is there a maximum number of search results that you get that you
Yeah,
can configure?
correct. Yeah, and all that is all configurable through the Optic API. So MarkLogic
Okay.
has a API that allows you to search across these different models and different types of
Mhm.
data. And we're going to go in there and limit the responses, right? We don't want to try to send our whole database to the LLM every time. So we want to narrow down
Right.
onto a key focus of content.
Right.
So I'm actually going to jump over to a IDE now. And LangChain gives you the capability of defining and wiring in things like chat memory. So as we're interacting with our chatbot, um, we can understand how many messages we can retain in in that interaction. Also, a chat language model. This is defined based off of the LangChain configuration. In this case, we're bringing in Azure OpenAI, where we can use these in conjunction with a data retriever that we write ourselves, right? And in this case, I created this Progress Data Platform query retriever that we'll use as part of our pipeline. We're using Spring Boot in this case. So we have a request mapping API slash fast track slash chat. We're exposing it this way so we can interact with the widgets themselves. And we start to build out our interactions with the large language models using LangChain. So we're going to create a query assistant that uses AI servers, and we're going to pass in a query assistant class. And this is actually another item that you would set up. In this case, you create a interface, in this case, query assistant, with a chat. And what this allows us to do is kind of provide our prompt, right? In this case, I'm saying you're a researcher, you're going to answer questions in a few sentences, use the text provided, use the chat memory provided. If you don't know the answer, just say that you don't know. And importantly, you should only use information you should not use information outside of the context or chat memory for answering, right? So we want to ensure that the LLMs are only using the information that we're providing it in the context. So the next thing we supply is the chat model, and this is the wired one based off of the configurations. We just specify the type of model we're going to be using in the application properties. The chat memory as we showed here in this message window chat memory. And now we're going to do our retrieval augmenter. And this actually becomes interesting here is that we're going to specify a content retriever, and this is where we implement the code for interacting with MarkLogic. And then the query transformer. And this query transform is an out-of-box one where we're going to actually compress the results. So as people ask additional questions, we're still retaining that context and that information from the chat memory. So coming into our query retriever, we need to, once we implement this interface, content retriever, it's going to require a few functions to be defined. And in this case, the retrieve function, which wants a list of content coming back. In this case, we create a database client for MarkLogic. And once we create the database client, we're going to use a row manager. We're going to use the Optic API to pull out rows of data based off those TDs that you see. That doesn't mean it's only row content. It will be a multi-model query, and then we'll get into that a little bit. We're going to create a classification client, and this is a classification client that's connected to Semaphore. And what we do here is now we're providing the user's question that they asked, what are the effects on glucose, for example, to Semaphore, and that is going to classify and give us back the most relevant concepts that are associated with our query. So as we do this, we're going to iterate through the results, and we're going to create a query. And in this case, we're using the OPCTS functions to build a OR query here. So we're looking for any content that mentions these the labels based off of the classification from Semaphore. We're going to say it's case insensitive, punctuation sensitive, and in this case, English. But we have a whole set of options that you can use if you have multilingual content. Additionally, since we classify contents with identifiers, we're going to look for the identifier of the concept in addition to the lexical values. And this will allow us to help with things like disambiguation or things like that, where Semaphore has clearly classified the content as one concept versus another. Well, while we understand Semaphore really enhances our capabilities here, not everybody has that. So this bit here is actually using the LLM to define some keywords as well. So when we search, we can also prompt the LLM for concepts based off that criteria, and we'll extract those keywords and do something very similar with looking for a lexical value. So finally, we take those two queries, and then we're going to create a end query against them, looking at those chunks as well as those queries expressions. We're going to generate an embedding based off the query as well for the re-ranking of the content. This is just using the standard embedding model that comes from LangChain. And we're going to set up our plan options for Optic API. And in this case, we're defining a different scoring method. By default, MarkLogic will use TF-IDF, but if you are using MarkLogic 12, we've introduced BM25 scoring. And what this allows you to do is, while the search operates similar to TF-IDF, it does take into consideration the length of the contents. So some chunks maybe be more dense than others based off of that abstract extraction. So we're telling it to take into consideration the length of the documents as well. And this is where Optic really comes in. And we're going to first search against all the relevant documents and get those using that lexical query. We're going to then join in that view that we've seen from our Gen AI chunks. And what this allows us to do is pull the original chunk metadata along with that vector embedding. We're going to limit to the first 20. And this is where we're taking the first 20 most relevant content, piece of a content based off of its lexical relevance. And now we're going to create a similarity score. And this is where we take the embedding that we generated from the question and compare it to the embedding that's in the chunk. This allows us to calculate a cosine similarity, and this is how many vector operations happen. What's a little unique here is that we're creating a hybrid score, and this score is taking the score from the lexical relevance plus the score from the similarity and combining them. And this allows us to reorder those or re-rank the results based off of that hybrid score. We'll finally take the last the top 5 of those, and we'll join in any article metadata so we can build in that citational link structure. So this query in just a few lines is really powerful, and it's hitting 3 different types of data models: graph using Semaphore, lexical search and document search from the MarkLogic search indexes and on the chunks, as well as the vector new vector capabilities. So a hybrid search we've been finding is the most beneficial to our customers. LangChain does expect content to be in a certain format, so we just iterate through those result sets. We get that information back and build that metadata up. So we know that we have a URI that we're referencing as the source, the title, the text, the scoring, and we build a content object. This is again from the LangChain framework. From that text and metadata. So we're creating a text segment, and we add those in and return those to the model. So when we interact with the LMs, we can get this information directly back, and this is what comes back from that response. So, Tushar, any additional questions about the APIs or what else you can kind of leverage at this layer?
I think I'm good here.
Okay. Mike, over to you to talk about integrating the React front end.
Thank you, Drew. Okay, so the UI in the application Drew just showed was built using MarkLogic Fast Track, and specifically the Fast Track chatbot widget. And Fast Track is a React component library like ones you may be familiar with, maybe you've used, like Bootstrap and Material UI. But the special thing about Fast Track components is they work well with data that is stored in MarkLogic. Fast Track works with many of the MarkLogic APIs out of the box, and it helps developers build MarkLogic applications faster and with fewer resources. So developers can build AI applications with the Fast Track chatbot widget. It lets you manage ongoing conversations with a large language model, and it works out of the box with the RAG endpoints that Drew was exposing in the code he was showing. But it also offers you full control of message formatting and the other RAG interactions if you need that kind of customization. And we'll show examples of this in code in just a moment. So here's a diagram that shows how Fast Track and the chatbot widget in particular fit into an application. So you install Fast Track using npm, and once it's installed, you have access to a number of UI widgets, including the chatbot widget. And the chatbot, as well as the other UI widgets, communicate with the backend via a special component called MarkLogic Context. And it's going to be sending the user questions from the chat to the middle tier, which then handles the RAG steps. So the middle tier is going to go get the relevant document chunks from MarkLogic based on the user query that Drew just described. It's going to send those chunks along with the query to the LLM, and the LLM is going to return its answer along with source information, citations to back up its answer. And that's all going to be passed back to the chatbot, which will seamlessly display that information in the UI. Okay, let's get in some code now. It's relatively easy to set up Fast Track in a React application. You basically just need to wrap it in a MarkLogic provider component. And that's basically going to tell MarkLogic Context, hey, where is the backend, where are the backend endpoints located, and how do we talk to MarkLogic? And if your RAG middle tier is set up to work with the payloads that Fast Track expects, and Drew set up those contracts and things on the middle tier as Fast Track expects, then this is actually really the only configuration you have to do to use Fast Track in the chatbot, and we'll see that. So the chatbot's going to send a JSON object to the backend. It's going to have the user's question as a query string here. It optionally can also pass a MarkLogic combined query in the payload. And that's going to allow your UI to send faceted constraints and other search information along with the user query to constrain what RAG documents, what chunks you get back from the backend to send over to the LLM. So that's an option you have with the Fast Track chatbot. And by default, these requests are going to go to the API Fast Track chat endpoint, but again, you can configure that to go elsewhere if you want. And the chatbot expects to get the following return from the backend: an output string that's basically the answer to the question that was posed, And optionally, it can also receive citations that explain how the LLM came to its conclusion based on the RAG chunks that it received. And out of the box, chatbot is going to see those citations, be able to display them if they're there in the UI. All right, so let's see the chatbot widget in action. So like I said, if we have that backend contract in place, all we need to add is just the chatbot component. So I've actually removed the chatbot here, and we're going to add it. Let's go into the IDE, and we're going to add the chatbot with 0 configuration. Save it. We're going to ask a question. Let's go to the UI. Okay, it's updated with the chatbot. We can ask it a question. And with minimal configuration, we're seeing the answer come back as well as our sources nicely formatted, and the conversation can continue. So you also have lots of options for customizing styling, adding additional information to the chatbot. For instance, we can add custom names, icons. We can seed that conversation you see in the UI with introductory messages, add placeholder information, truncate the sources when they're above a certain length, and show a restart button that'll allow you to clear the conversation in the UI. So let's see that working. So I'm going to add a chatbot with additional configuration props to our UI. And I'm just going to have to add some additional code so that we have the objects that the props are referencing. So let's get that in there into our component. I'm going to save it. Let's go back to the UI. And now I have custom name, icon, placeholder text. We have the reset button turned on. And again, I can ask the question. All right, so that's working. So last thing I'll show is, let's say your backend is involves different requests and responses. Maybe it's going to a different endpoint. That's no problem, because you basically have full control of what the fast chat chatbot is doing if you need that. You can configure chatbot to access any endpoint with a parameters object, and this will override that provider information that we saw earlier. You can handle message submission with the on message send prop. That just allows you to apply a custom event handler for that. And you can handle source clicks to open those sources in, for example, a window. And Drew saw that happening, and we'll see that happening in a moment after we update the code. And you can also have the chatbot send an additional call to the backend when that reset button is clicked. And that can tell the backend to say, erase any memory history you might be maintaining in state, so that we can start our conversation anew. All right, so let's do that. So here's the additional chatbot configuration with those event handlers I just described and the additional parameters. Let's actually add those event handlers. Into our code. And let's ask our question again and see what we get. All right, so just to prove that event handling and message processing is happening, we're seeing some additional text added to the response thanks to our event handler. The sources are formatted a slightly different way, so that's working as well. And when we click a source, we're opening a window, doing an additional call to get the document information and displaying it. So you can drill down into your sources and confirm that what you're getting back from the LLM is good. All right, so one other place you can see, and it'll help you understand the chatbot widget and all the other widgets in Fast Track is in our Fast Track Storybook application. And this comes with the Fast Track release. You can run it locally. And on the left side here, you can see all the current Fast Track widgets that are available. We can check out the chatbot here. We can see the chatbot shown in the browser, similar to what it'll be shown in your app. And you can also go down and see all the available props that are available to you for customizing the chatbot widget. All right, so that is Fast Track and the Fast Track chatbot widget that can be used in your MarkLogic AI applications. Drew and Tushar, back to you.
So just wanted to just to let you know, some of the features that we showed today are part of MarkLogic 12, specifically the vector support in BM25. Please join our customer validation program to get started. We can provide you with an early access copy of MarkLogic 12 to test out. Additionally, there are more RAG examples on our GitHub, so showing the different ways to split, how to create vectors, and also integrate LLMs. These examples are in multiple languages, whether they're Java, React, Java or Python, etc. And that's it. I'm going to open it up to questions now. Feel free to add your questions in the chat, and we will be happy to answer them.
Not seeing any questions yet. So we have one question, Drew. Can we access the sample code?
Yeah, so sample code will be released soon in a blog series that steps you through each part of the workflow that we showed today, and gives a little more context onto the kind of reasons why and how you go about building the application.
Yeah, we'll also be releasing an early access of the upcoming Fast Track release in the coming days, and that'll be available as well.
So the other question is this chatbot based on OpenAI?
Yeah, so in terms of this integration, LangChain gives you the option to integrate multiple large language models. This one in particular was using Azure OpenAI. However, you can plug into other models, including offline models.
Okay, and that was the other question. This was demonstrated with Azure OpenAI. Can we use other LLM models with it? Eric mentioned, I think you all are muted. No, we aren't. So might be some issue with your audio.
Yeah, so can the RAG solution demonstrate be used with other LLMs besides Azure? Yes, it can be. And as Mike showed too, if you like to write your middle tier in a different language and different set of endpoints, you can configure the fast track widget to take those into consideration.
Yeah.
So while we wait for other questions, I had bottled up a couple, so I'll ask that. We talked about how we can mine the concepts out of documents, but let's say if I already have a lot of documents in MarkLogic server, how does semaphore work in adding tags to it? Does it do it all at once?
Yeah, no. So you can do a reprocessing of documents to go through the content. You can also selectively mine data out of MarkLogic. MarkLogic also has a pretty powerful index called co-occurrences. So where one term exists with another term in a particular index. So there, in Semaphore, there is a side panel where you can see and tap into that repository that you have in MarkLogic and use the particular concept that you are on in the UI to look for other co-occurring terms and phrases.
Okay. And talking about chunking, so the chunking is generally defined by size, number of characters, but is it possible that that the chunk actually splits at a point where the logical meaning of that content is missed out? So how do we make sure chunking is done right?
Yeah, so there's configurations also for overlap. So you may want to, like, say you're chunking on the paragraph, or you may want to take a bit of the paragraph preceding it and the paragraph before it to have some overlap between chunks so the context isn't completely lost. Additionally, as you're doing the classification, that's another layer of context added into those chunk documents as we showed. So it will also have the semantic meaning of the text that it was generated from.
All right. So I have another question in the chat, which is, can we get the recording of this session? So I guess you will be able to get the recording of this session. Will it be shared? I think it will be shared on CVP. So if you guys are there on CVP, you should be able to get it. And if you're not, it's easy to just go to the Progress Committee website and join the CVP.
Yep.
In fact, along with that,
the webinar recordings will also be available through the webinar landing page.
Right. The other thing is we'll also be publishing a white paper or ebook of sorts that basically talks about what we covered in this session. So that will be another supplement material that you can use.
All right.
I don't see any more questions.
Yep. Thanks everyone for joining today. Feel free to reach out after the session. You can either contact your account manager or feel free to reach any of us on LinkedIn.
Thank you.
Thank you.